Okay, welcome to the grand finale here. We are finally wrapping up our factoring notes. This is factoring notes part 5. And what we're going to do, there's not a whole lot of new concepts that I'm going to introduce here. We're just going to take multiple steps now in all of the things that we've started to master. And so we're going to call this section F. And the title of section F is Factoring Completely. Okay? So the directions on a problem like these might say factor completely and then give you a polynomial. Okay? So I've got 3 examples here for you. So we are now on example 14. Okay? And on example 14, I want you to factor completely. I'm just going to write factor because I think you understand. I want you to factor 5x squared plus 15x plus 10. Okay? Now, remember how I've been telling you on every example before this, find a GCF. And you're like, why? It's always 1. And you know I hate that word always. And so, actually, don't hate the word always. We should have a conversation about that word a little bit later. But anyway, I always say, find, there it is, always. I commonly say, find the GCF. Okay? And so if you notice, you've got a 5, a 15, and a 10. And I'm hoping that you understand that the greatest common factor there is a 5. All of those coefficients there can be divided by 5, okay? And so we're actually going to factor out a greatest common factor of 5. And so if we take a 5 out of a 5x squared, we're left with x squared. If we divide 5 out of 15x, you're left with a positive 3x. And then if you divide 5 out of 10, you get a 2. And now this is where you would normally check your work, right? You would distribute to get 5x squared plus 15x plus 10. And if you want to do a quick check in your brain to make sure that you've done that, then you can. However, with a problem like this, we actually have to keep going because now we have a trinomial here that can be factored further. And so we're going to bring the 5 down as a GCF. We can't get rid of it, but we're just going to kind of ignore it. It's like our little brother, right? So we're going to come down here and we're going to say, okay, well, now we can factor this. So ignore the 5. Pretend it doesn't exist. Okay, now this is factoring notes part 2. We know that this has to be x and x, and the only way to get back here at 2 is to do 2 and 1. Okay, and we know that they both have to be positive and positive. And now let's check our work. And when we check our work, we're actually going to check in reverse order. So you could distribute that 5 first to check your work, but I think we should probably start here. Okay, that way if we know that we're wrong, we don't have to change everything. All right. So here we go. We've got an x squared. Oh, sorry, we still have a 5 out on the end. Don't forget the 5. An x squared, and then plus x plus 2x plus 1. And then we've got a 5 on the outside, so we've got x squared plus 3x plus 1. And then that turns out to be 5x squared plus 15x plus 5, which is exactly what we wanted to get. Okay. So the complete factored form of something like this would be 5x plus 2x plus 1. You have to have all 3 of those. You can't, a lot of you are just like, well, let's just divide by 5. And essentially that's what you're doing, but you can't get rid of it. You still have the 5. You just got to get rid of it, okay? You can't get rid of it, sorry. Okay, let's look at something actually that is kind of, it's a little bit different, but still along the same lines here. Okay, we've got example 15. And I want us here to factor in example 15, negative 4x squared minus 8x plus 5, okay? And what you should notice here is, okay, we got a 4 and an 8 and a 5, and those don't have anything in common, Bacham. And I'm like, yeah, you're right. However, okay, what I want to draw your attention to, and we haven't talked about this quite yet, is the fact that there is a negative out in front there, okay? And because there's a negative out in front there, we have to take that out actually as a greatest common factor. We're going to factor it out, okay? If your lead term has a negative, we're going to take it out. We're going to put it out here on the outside. Say, okay, that's annoying. Let's get rid of you. And so basically, when you divide everything by negative 1 here, you get the same term, just the opposite sign, right? If you divide negative 8 by negative 1, you get a positive 8. And if you divide positive 5 by a negative 1, you're going to get a negative 5, okay? And you can always distribute that -1 to check that you've done that right. All right. But now we have another trinomial that can be factored farther. And what's cool about this is now this takes us back to the previous notes that we did. Okay, so our value out here is greater than 1. And I'm just going to go ahead. I know what the answer is. This is one where you would have to guess and check. I always like to start with 2x and x, if I'm being honest, if you've got a 4. Okay, and that's helpful because now it doesn't matter where we put the 5 and where we put the 1 because they're either way it would be there. Okay, and then I'm going to do a +5 and a -1. Now, again, you would have to, guess and check, but I'm still going to check my answer just in case. I'm going to leave the -1 on the outside, and I'm going to deal with this first. Okay, so 2x and 2x is a good 4x squared. 2x and a 5 is a plus 10x. -1 and 2x is a -2x. And then that's a -5. So then you've got -1 and then 4x squared plus 8x minus 5. And then we finish off by distributing that -1, which would then give you a -4x squared minus 8x plus 5. And that is exactly what we needed to get. And so we know that we've done this correctly. That trick of factoring out a -1 is super important, you guys. So make sure that if there is a negative out in front, if a negative is the first thing that you see, take it out. Okay. Okay, one more here. Final example. Oh my gosh, I can't believe that we made it. Let's look at example 16. 16 is such a great number. I can't believe we're ending on it. It's perfect square. It's 2 8 counts in a dance or cheer routine. Man, I'm so glad we ended on 16. Okay, 16. Here we go. I want us to factor a 4z cubed minus z. You're like, whoa. Okay, but we start it exactly like we do everything else. Let's find a GCF. Okay. And what you're noticing here is that, well, this doesn't have a 4, but it does have a z. And notice that they both have a z in common. So we're actually going to take out just a z as a greatest common factor. Okay? And so we take out a z. And then we're left with 4z squared minus 1. Okay? And I know that we haven't talked about exponent rules, but I think that you talked about them enough last year to know that that's okay right there. Okay? And now we have a perfect or a difference of 2 squares there. Okay? Watch. Because the first one's a perfect square and the last one's a perfect square. So we keep the z on the outside. All right? What if we had a 2z and 2z? And then the things that get us to 1 are 1 and 1. And then if we had a plus and a minus there, let's check our work. So bring down this z here. Okay? And then 2z and 2z, that's a 4z squared. 2z times a -1 is a -2z. 1 times 2z is a positive 1z. And 1 and -1 is -1. So then we're left with z times 4z squared. That goes away. Woohoo. Then you've got -1. And then the final step would be to distribute that final z there, just like that. Okay? All right, and that is exactly what we needed to get. And so that means that our final answer here is all the way finished. Okay? And so you're probably thinking, Bacham, how in the world am I going to remember when I'm done? Like, how do I know? And that's what we're going to kind of spend some class time doing. It's thinking about, okay, what does it look like if it can't be factored anymore or can't be factored at all? But it's important that we know what it does like if it can look like if it can be factored, so that if it can't, we know for sure. Okay, great. So come with questions, and thanks for watching. Congratulations, you're done.